Hello everyone and welcome to today's webinar, A New Level of Safety in Electromagnetic Fields with the new Narda FieldMan. My name is Peter Shields and I'm pleased to introduce our special guest presenter, Holger Schwarz from Narda Safety Test Solutions in Germany. I'm sure many of you have met Holger before and it's great to have him back today. In this session, we'll be discussing the latest technology in EMF meters, the new Narda FieldMan. As you know, exposure to electromagnetic fields is a growing concern in our society. With the advancement of technology and the increasing use of electronic devices, it's crucial to have reliable and accurate measurements. Now, without further ado, I'd like to welcome Holger Schwarz to present the new Narda FieldMan.
Thank you very much, Peter. Good afternoon, Australia. My name is Holger Schwarz. As Peter just mentioned, I'm working for Narda Safety Test Solutions here in Germany, sitting in my home office and giving you this presentation regarding the FieldMan, our new field strength meter. Okay, here we go. Before we talk about the instrument, let's talk a little bit about the history of Narda itself. So our roots are coming from the US. Narda Research and Development Associated is how the name Narda was created in 1953. I myself started here at W&G, or Wandel & Goltermann, which is a company which will celebrate its 100th birthday this year. And our division there to create electromagnetic field strength meter was founded around about 1992. We also have a third partner on board, which is since 2001 also a member of the Narda family, which is called PMM. And here you see some old field strength meter created by the different divisions. So on the left-hand side from Narda US, in the middle, one of the old W&G meters already branded with Narda, and on the right-hand side, the PMM 8053. So you can see Narda created already a huge amount of field strength meters. So the question comes up, what makes the FieldMan really being a difference? Okay, because field strength is still a field strength, and 20 volts per meter will be also on the FieldMan, hopefully 20 volts per meter. So as I'm in sales and marketing, I would prefer to hear features like, what about the ease of use? What about measurement precision, documentations, innovations? Or what my boss loves to hear is, what about cost of ownership of the instrument? Can FieldMan do there anything new? So let's go first a little bit through the features of the FieldMan and to compare them against those arguments. And the first thing, when I switched on FieldMan the first time, my reaction was, wow, what a display. So the numbers, the values you can read out on the display easily because it's so big, all the numbers, and I'm nowadays a little bit older and I need reading glasses, for example, but not for the FieldMan. So it's really readable without glasses. And if you have once forgotten your glasses in your car, you know how important it is. You don't want to go down from the tower again and pick up your glasses from your car. And it's also readable from any angle, and you can also read it in bright sunlight. So the display is marvelous. So please do me a favor, try to get a FieldMan, switch it on and put it beside your old instrument, and you will say, wow, what a display, like my first reaction. And really there's everything you need on the display. So what you can see here is the instrument itself. So for sure we have the probe connection. We have a status LED brightness sensor, because if it is dark environment, maybe the display can be too bright. So it can reduce its brightness, or if you have forgotten your torch, you can even use it as a torch. Okay. So there is a microphone built in, a humidity sensor, a loudspeaker. So not like with NBM, you don't need anymore a headphone. You just can listen to your voice here by the loudspeaker, for example. Then, like on your smartphone, you have here a status bar with the most important information like date, time, is GPS available, what is the charging of my battery. Then followed by the probe information, which kind of probe is installed, and for sure, like you know it from NVM, it's in all the calibration parameters and so on are taken over fully automatically. And then we come to the most important fact, the measurement value. And you can see here at the moment the actual value, but you can also see the maximum, the minimum, the max average, the average, all three axes. So everything is there and big enough to be readable even for elderly people like me. Parallel, it's also showing you a little graph. And here, for example, we see the average value and the actual value. So if you're in a place where you have sometimes a little bit overexposure due to two-way radios or beamforming antennas, for example, then you can control here. Yes, the current value is, let's say, at 113% of standard, but the average value is still below the limit values. So everything is visible. The only thing which you might maybe miss is it's not a touch screen. But we said we don't want to have a touch screen because we need, again, the shielding of the screen. We want that the meter can operate in field strength up to 200 volts per meter. And also we want that you keep one hand for your own safety. So this is really an instrument for one hand operation. So we have here 4 hard keys. And here you see the symbols for the hard keys, and you can control the whole instrument by one hand. As you can see here in this picture, you just need your thumb. And nowadays, all our thumbs are well trained by our mobile phones. So you can control the entire instrument just by your thumb. The only thing which you can't operate by your thumb is here the on and off switch. I believe you can't see my mouse. The on and off switch, which is at the left hand side, so that you cannot switch it on and off without intention. Okay, so we said, like sailors know one hand for the man, one hand for the ship. We can also say one hand for the instrument and one hand for your safety when you are standing on a tall, windy tower and you want to be sure that you take the elevator down, nothing else. So when we go to the data sheet, we see here a lot of arguments. So for example, isotropic probes are available from DC from 0 Hertz up to 90 gigahertz. And so in the past, when you look to the portfolio of Narda instrument, if you wanted to do something between 0 and some gigahertz, you needed 2 instruments. You needed, for example, the NBM and the ELT, or you needed the NBM and you had to connect the cube, this electromagnetic field cube, up to 400 kilohertz and to measure the low electromagnetic fields by the cube. But this cube was not the perfect solution for, let me say, industrial environments where you didn't have any problems with this electric field, but most important thing are magnetic fields inside of industry. So this will change with the FieldMan because we only have one single base meter, and you can also connect it to the low frequency probe. Okay, just one field strength meter, and you can connect whatever you need. And it's very, very handy because now you can reconnect the low frequency probe also directly to the instrument. So this makes it quite easy to use, and as you only need one basic meter, reduce your cost of ownership. Next arguments are digital probe interface, no more meter calibration. So what does it mean and what is a digital probe interface? So therefore we would like to go a little bit into the basics of such a field strength meter, especially in the high frequency, for example. There we have the sensor, the dipole, and up in the head of the detect probe, and we have the detector inside. And then 2 lines, 2 high impedance lines go down into the basic unit, go via a mechanical connector into the basic meter, and there you have the amplifier and analog digital conversion and so on. but talk to our service department. This connector is always a little bit, even if you use a high sophisticated connector, you have dust, you have dirt, you have humidity, and you have very, very little current or voltage which is flowing through this connector. It's always a little bit difficult, this connector. Compare it with an analog vinyl disc player. So analog is analog. We change it, and now, due to the fact that the components are nowadays available in such small housings, we can now put the amplifier and the analog digital converter into the probe, and the basic meter is nothing more than a CPU and a display. So the full meter is already inside of the probe, and yeah, the basic meter is just a display. So this means the connection we are now having is again a connector, but it's now a digital connector, and it is as rugged as a CD player when it plays back a CD. So much more rugged in transmission and has no longer a direct impact to the measurement value. It works or it doesn't work. Okay, nothing in between. What we are using is the traditional USB-C connector. I think I don't have to make them much advertising because mobile phone manufacturers do it already for us. But I personally love the USB-C because it's very, very rugged and yeah, easy to handle, absolutely easy to handle. So even it has less influence when you use, for example, an extension cable. In the past, for the EMR, for example, we provided those kind of extension cables between the probe and the basic meter, but there were some weaknesses. So you had an additional analog connector. Now we have two. Movements of the cable created ghost field strengths. This means if you're working with max hold, you had field strengths inside of the screen, which never happened. You had the impact of a metallic cable in the field, means you influence the field itself, and you can also have a pickup of signal by the cable. So with the FieldMan, we now have a digital cable connection. So the analog, the movements, and the pickup will disappear as weaknesses. What only remains is the impact of the metallic cable to the field. To sort this also out, you can use a new adapter, which will come up soon, a so-called optical probe repeater. He will make out of the digital electrical signal a digital optical signal, and then you can connect the basic meter via fiber optic to the probe, and then you have really the perfect solution for measuring with electric field probes in high frequency fields, but not the probe directly connected to the meter, but via a fiber optic cable, for example. The other thing is it supports the direct connection of the measuring probe to the computer. For example, if you are in car manufacturing, you love to measure, for example, at different points of a seat inside of a car. So this is supported now directly. You don't need the meter anymore. You just can connect the probe directly to your computer because it's USB-C. Okay, attention, it's not plug and play because there is no driver inside of Windows and so on to read out the results of our probes. There is an API necessary, but this is something you can solve. The important information is you can directly connect the probe to your computer. No basic meter anymore necessary. There is rugged, we mentioned already. What is also important, the calibration of the meter is not required because the meter doesn't have any direct impact to the measurement result anymore. Okay, and so if you have a single basic unit and a single probe, the digital probe interface saves you money. Easy, because you just have to give the probe for recalibration when we talk about traditional calibration. When you have a single basic unit and multiple probes, for sure, again, saving money. And during calibration of a probe, remaining probes can still be used because you just give the, let's say, the 3 GHz probe for recalibration, but with the 6 GHz probe, you can continue doing measurement because you don't have to give away the basic meter also for recalibration every 2 or 3 years. Okay. Otherwise, during recalibration of the basic meter, you wouldn't be able to do work because the basic meter is gone. Okay. And when you have multiple basic units and multiple probes, again, it saves you a lot of money. It becomes even more drastic when we talk about accredited calibration. Accredited calibration, there you had to send back the probe and the meter because they were calibrated with each other. Okay, so here you just have to send back again the probe, which saves you money, but it becomes more interesting if you have a single basic unit and multiple probes. So for each probe in the past, it was necessary to send back the basic meter. This is no longer necessary. Okay, only the probe has to be returned. And in the past, when you were looking for after accredited calibration, there was no interchange between different basic meters and different probes possible. This will not longer be valid if you're using the new FieldMan because the field strength meter is just a display, not more. And so by this, you have again the full freedom and the full possibility to interchange meters and probes as you like. So also what we integrated is a so-called sensor test. So whenever you connect, for example, such a probe to the basic meter, an automatic sensor test is provided. And remember, in the past, you had to use such handheld transmitters to check the probe. This is no longer possible. So when you connect the probe to the meter, it will automatically look for shorts or open circuits and will say, all okay with the probe, you can continue. Another thing is there will be a complete automatic temperature control offset correction. So you don't need to zero anymore the instrument. The instrument does it fully automatic by itself. Okay. And maybe not so interesting for Australia because normally it's warm there, but I heard that you have the first snow also in Australia. So especially for lower temperature, we now do an automatic compensation of, for example, the diet behavior that is losing sensitivity to lower temperature. This will be also fully automatic now compensated. So finally, the amplifier, which is making such kind of offset, can be fully controlled nowadays by the electronics, and you don't need any more zeroing of the instrument. Means all these factors of the digital probe interface will make it easier to use, will have a positive impact to the measurement precision. It's an innovation because it's not really the first time. The area monitors, they also have digital probes interface, but for a handheld field strength meter, it's an innovation. And it also reduces your cost of ownership. So when we also look for measurements against the standard in percent of standard, for example, we can provide here also for the high frequencies, again, so-called shape probe, but also for the low frequency, we will have so-called weighted peak measurements according to different standards. So remember, for example, the low frequency, it's easy if you have a single signal, if it is compliant or if it is non-compliant. And but what will happen if you have a multiple frequency environment? Switch power supply is a perfect application for such kind of problems. So how is the sum of all those frequency components compared to the standards, and how do I add all those components together, including the phase information and so on, can be quite complicated. So with a WPM weighted peak measurement, this will be very easy because you just see a result in percent of standards, and that's it. Okay, it does all these computation for yourself. So what does WPM or WRM or SCD mean? So WPM is weighted peak measurement or measurement against the standard using the peak detector. Okay, and parallel WRM means measurement against the standard using RMS detector. And SCD means the instrument can perform both measurements. Okay, very easy in that way. So the SCD means both measurement methods are available in EFA 200-300, ELT 400, EHP 50F, and now also in FieldMan. So where is the improvement by the FieldMan? It's quite easy because the EFA 200-300 is discontinued since 10 years maybe, so no longer available. Good luck on eBay. ELT 400 is still available. It's standard compliant, including the 100 centimeter square antenna, but the standard inside is hardware. So if the standard is changing, you need a new instrument, which is bad for your cost of ownership. EHP 50F is still available. The standard is software, but the antenna is not 100 centimeter square as several standards request. So this will all change with the FieldMan and the new low frequency probe BFD 400, which will be available mid of this year, I believe. And there the standard is software. So whenever the standard is changing, you need an update. And the antenna itself is 100 centimeter square. Okay. And do you remember those old application pictures if you wanted to see in low frequency how is the function of the signals versus time, or you wanted to make an FFT? This is something the basic meter can do in future on its own. You don't need an oscilloscope or a spectrum analyzer anymore. The basic meter can show it to you, or as I already said, connect the probe directly to your computer. Because the spectrum analyzer is already inside of the probe itself. So when you want to make measurements against the standard, remember in Australia, we are also having those frequency-shaped limit values. And if you have a so-called flat probe like the 6 gigahertz probe, it tells you it's 0.66 milliwatts per centimeter square. And the shape probe is telling you if it is a transmitter at 100 megahertz, it's telling you 330% per standard. You have a problem. So this is something you cannot read out of 0.66 milliwatts per centimeter square. You are not sure because a broadband meter doesn't know the frequency. It's you who has to know the frequency. But you are not a spectrum analyzer. If the same signal appears at 3 gigahertz, the flat probe will tell you again 0.66 milliwatts per centimeter square. Good or bad, you don't know. The shape probe will tell you directly it's 66% of standard. So here you have a clear indication directly on the field strength meter, good or bad. How is it realized? When we look into such a meter, you can see we have the sensor and the detector, and there is nothing in between sensor and detectors. And if you have flat standard, for example, you have such a flat frequency response from the meter itself. Inside of a shaped probe, we have a so-called shaping filter inside, and this is changing the behavior of the frequency response of the probe before it goes into the detector, which is completely inverse to the standard, and it's compensating the frequency response of the standard and makes you again a flat percentage, flat judgment against standard directly. But this shaping filters are real little miracles because they have to operate over a huge frequency range. And yeah, so those powerful time analysis and weighted peak and percent of standard makes it easier to use, and also documentation is easy because your measurement report is already directly on the screen of your instrument. 35% of standard everybody will understand easily. So we have also Wi-Fi and Bluetooth connectivity inside of the instrument. This is new, and we are also having in preparation a smartphone app. So in the past, we said, we don't want to have any transmitting devices inside of our instrument, but on the other hand, we wanted to make your life a little bit easier. And so, for example, when you take photos, in the past, it was necessary that you had to go back into the office, download the photos from your mobile phone device, and put it into your measurement report. Nowadays, it's possible that you connect your mobile phone to the field meter. You can use your mobile phone as a remote operation control for the field strength meter for sure, but you can also say, send your pictures directly into the field strength meter, that all results are together, and you can tell the field strength meter, please back up your measurement data onto your mobile phone, that you also have a backup of your measurement data. So both instruments have the same information on site, the field strength meter and your mobile phone. And if you give away, for example, the field strength meter, you can still go back into the office and you have everything on board of your mobile phone. Or you connect your mobile phone to your computer and you can download everything. One of our ideas was also to put in a camera into the FieldMan, but we said, no, we don't like it, because we know there are many, many customers who don't like to have mobile phones inside of their company, like military customers, research labs, and so on. They don't like to have cameras inside of their labs. And that's why we said, okay, no camera inside of FieldMan, but a strong relationship with a mobile phone, that whenever you are allowed to carry a mobile phone with you, that you can interconnect with your mobile phone. So this makes it even again easy of use, perfect for documentation, and again, it's an innovation in field strength meter. For sure, we have a built-in GPS receiver and a rangefinder. GPS is nowadays standard. Rangefinder, what the hell is this? So this is a little ultrasonic distance meter, which can measure the distance from ground between 25 centimeters up to 4 meters. So it's also recording the height above ground, or if you want to do, for example, spatial averaging and so on, the height above ground is directly recorded with your measurement result. And also there is a little mechanical protection against the dirt and dust for the ultrasonic rangefinder things. You can also use this as a high stand, so that if you connect a huge probe into the field strength meter, there is no mechanical stress to the connector itself. So again, ease of use, documentation, innovation. We also have a micro SD card inside of the field strength meter, so that you can easily take out your memory, your setups, and so on, and you can personalize the instrument by a micro SD card. Or you can give the instrument to your colleague. You keep your micro SD card, there is everything on it. Ease of use, documentation again. Climatic sensors for temperature, humidity, and air pressures are also built into the FieldMan, because many standards asking for this. So please record also the temperature, humidity above 95% air humidity. It's not longer measuring, it's gambling. So it should be reported inside of your report that you've done it under controlled conditions, okay? Everything is directly recorded with your measurement results. The temperature and the humidity itself are directly displayed in the screen of FieldMan. Here you can see the display of FieldMan. You can see here temperature, humidity, and on the right-hand side, also the distance above ground. So again, ease of use, documentation, innovation. And I once talked to introduce the instrument to a German measurement provider, and he said, oh, yes, you are right. I didn't do it during the last years. I only told our customers what is a field strength value, but also the standard in Germany is asking for humidity, temperature, and so on. And by the FieldMan, I now have an advantage against my competition, because I can show them, look, I report everything according to the German standard, and I don't need a second instrument. For sure, FieldMan has all kind of connectivity like optical interface, USB-C, Ethernet, and wireless. So it's really on a modern design. We have rubber protection again for all those ports, so that you can also connect fiber optic cable, for example, and so on. And the instrument itself is IP54 protected. So very good for ease of use, not the protection, but the connectivity and for documentation. The battery itself, it's a huge battery and it can operate around about 16 hours, the instrument. But remember, it has a USB-C charger. If you want to extend the measurement length, for example, you can use a charger, which we don't recommend. We recommend to use one of those power packs for your mobile phone, which you can buy in every supermarket. And by this, you can make the life of the battery longer. You can exchange those batteries by yourself if they are broken. You can't buy them via Amazon, for example. You have to buy them from us. Sorry for that. But for the charger, you can use, I believe, any kind of charger as long as it provides 1 ampere, I believe. Okay, so USB-C really makes life easier. Here are little pictures from our environmental testing. So it's splash-proof IP54, minus 20 degrees Celsius, I believe, is not a problem in Australia, but plus 50 could be more important for you. The digital probes, we're now introducing a huge number of new probes because they all need the analog, digital, and the preamplifier inside of the probe. So we have a huge number of new probes showing up. Here you can see the different application, which probe you need. You will find these information also into the data sheet of the probes because this will be now too extensive to explain it all. The most important probes in the near future for low frequency will be this one, which has, again, these measurements up with 100 centimeters square and has a really full spectrum analyzer built in. A similar probe with 3 centimeters surface will also come up soon. A probe accessory is also important. One of the most important factors is, as you can see in the middle, yes, you can connect the new probes directly to the field strength meter, but we will also provide an adapter that you can connect your old NBM probes to the field meter, to the FieldMan. Okay, very important. So if you don't want to interchange, we would love that you interchange all your probes, but you can say, okay, my first investment for this year is maybe just the FieldMan and a 6 gigahertz probe, but the 60 gigahertz probe from the NBM, you just buy one of those adapters, only one is necessary, then you can connect all old NBM probes. For operating the instrument from a little distance, remember, we will also provide you the probe repeater, as you can see it on the right-hand side. On the left-hand side, you see a new instrument called LR01, which can be also connected via a fiber optic cable to the FieldMan. And then you can also connect all Narda or PMM probes from the area monitors or from the 8053. So FieldMan is really the instrument which can handle also the history. What is missing are the old EMR probes, but I don't know if any of EMR probes survived during the last 20 years. Options and sets. So for sure, we are providing such a case that you can put in 5 different probes, including those big probes and the cube, whatever you need. You can put in a Redman, you can put in the FieldMan itself. So everything on board you need. And a PC software, Narda TSX, will be provided also. And remember, in the past, you needed a software for the Redman, you needed a software for the SRM, you needed a software for the NBM. Our promise is that Narda TSX is the last software you need from Narda, because all future product must be compatible with this software. So this is a new base, and you only have to install once the TSX. All future products, safety products, will be able to work with TSX. That's your last safety software for the computer. By the way, it's free of charge, available on our homepage. So the summary will be given. I hope it's also sharing now my computer's sound. Otherwise, I hope we have subtitles here.
Why a new EMF measuring device for the same old measurement? It will only give the same result? Because the Narda FieldMan is the smarter solution. Just the one instrument for every measurement. From 0 to 90 gigahertz. So it covers all applications for non-ionizing radiation. And of course, it conforms to and covers all the current standards. Its groundbreaking operating concept is as intuitive as your smartphone. A huge jump in user friendliness and efficiency. It is often really just the little things that make life so much easier. For example, the bright, high-resolution display. It can be easily read even in very bright sunlight. It is no problem to operate the instrument when wearing gloves. It provides a wealth of detailed information at a glance. Or what about the distance sensor, which, quite simply, displays and records the exact measurement height? And of course, climatic data and GPS coordinates are also recorded at the same time automatically. An automatic self-test of the 3 sensors ensures that everything works perfectly, and no external equipment is needed either. And the instrument is protected to IP54, so no need to worry about a rain shower. Just keep on working, error-free and reliable. FieldMan makes things easier both before and after the measurement too. Our revolutionary digital probes are the product of decades of know-how from the market and technology leader, Narda. If recalibration becomes necessary, only the probe itself and not the whole instrument needs to be returned. So you can keep on working, because the probes and instruments are all completely interchangeable, even for devices with accredited calibration. Evaluation of the measurement data is easy with the new Narda TSX software. You will be able to use this software to evaluate all measurements from future Narda instruments too. In fact, you can even use your smartphone to record additional information, such as street maps, photos, or videos, and transfer these directly to the FieldMan for evaluation together with the measurement data. The FieldMan gets you the measurement results much easier, faster, and more conveniently than ever. That saves time and money. It really is the smarter solution.
Don't seem to be getting any questions, Holger.
No.
You must have covered everything.
Or the video.
Yeah. Well, the video will be in the mail out. I suppose if we've got no questions, I'd just like to thank you all for joining us today for this webinar on the new Narda FieldMan. I hope that you found the presentation interesting and valuable. If you've got any further questions or would like more information about the new Narda FieldMan or any of our other products and services, please don't hesitate to contact AirMet Scientific. Thank you all for joining us today and hope to see you at our future events.